Hey everyone, welcome to my participation evaluation video for this course. Today I'm going to be walking you through some key concepts from week 1 lectures, which is all about getting introduced to Java coming from a Python background. Let's get into it. So first things first, what even is Java? Java is a statically typed general purpose programming language that was developed back in 1995 by James Gosling at Sun Microsystem. The big idea behind creating Java was platform independence, which is made possible, which is the ability to write a code once and run it on any device, and that's made possible by the Java machine, by the Java virtual machine, or the JVM. Java works similarly to Python, but with one important difference. When you write your Java code, you compile your file using the command javac and your file name .java. Javac stands for Java compiler that takes your source code and converts it into a bytecode. And then to actually run the code, you use Java and your file name, which passes the bytecode to the GIT compiler inside the JVM. The GIT compiler converts the bytecode into a native machine code that at a runtime, so your computer can actually execute it, where the bytecode can run on any machine with a compatible JVM. That's where the saying comes, write once, run anywhere, promise of Java. Right, now let's talk about how to compare it to Python. The first thing you'll notice about Java that it's much more verbose than Python. For example, the basic hello world example, in Python you just print hello world, but in Java it's more like complicated and needs more words added to it. And I'll add the picture right here for it for the example. They do the same thing, but Java requires a lot more structure to it. The reason that is Java is more of a verbose language type thing, because everything in Java must be in a class, but in Python lets you write the functions and any statements outside of any class, but Java does not. Every piece must be wrapped in a class. So what does all the boilerplates actually means? Let's break it down. Public, this is the access modifier, and it means that the message is accessible from anywhere. The JVM needs to be able to call main when your program starts, so it has to be public. Static, this method belongs to the class itself, not to a specific instance of the class. The JVM does not create an object of your class before calling main, so it needs to be a static. The third one is void, and this means the method does not return anything. Main is the entry point, and the JVM always looks for the method called main to start execution. And lastly, the string one, which allows you to pass command line argument to your program at a runtime. And this exact signature is required by the JVM. If you change it, the JVM won't recognize it and at the entry point, and it will throw an error for you when you try it out. And just like Python, Java supports comments, and there's actually 3 different types: a single line, multi-line, and documentation comments. The single line starts with double dashes, and it's great for quick notes or temporarily disabling a line of a code. And the multi-line ones, it starts with a slash and a star, and it ends with a star and a slash. And they're used for longer explanations or blocking or disabling a whole block. And lastly, the documentation comments, it starts with a slash and 2 stars and ends with a star and a slash. And they're special because Java Doc tool can process them to automatically generate HTML documentation for the code. And one thing that trips people coming up from Python background is the semicolons. In Java, every statement ends with a semicolon, which the compiler uses it to know where one statement ends and another begins. Forget it and you'll get a syntax error. In Python, you use a new line to separate statements, and you never need a semicolon there. In Java, they're not optional. Similarly to that, Java uses the curly brackets to define blocks of codes for like classes, methods, loops, and conditionals. But in Python, we use indentations to do this. In Java, indentations is still good practice, but it's the braces that actually matter structurally. And this one is a big one. Java is a statically typed programming language, which means variables must be declared when you create it, and it cannot change. For example, in Python, you do x equal 5 or x equal between quotation mark hello. In Java, you do integer int number equals 5, and number equal between quotation mark 5 words. The Java compiler catches the types before even running the program, which catches bugs earlier. This also applies to methods. You must declare and define what type of method you'll be returning for, and I'll put the example here. Compare that to Python. Python, you don't have to define the method, so no types needed there. If method doesn't return anything, we use void to the return type. We already saw the public one in the main method, but Java has a full system of access modifiers like public, private, or protected. But in Python, we used a single underscore, like the underscore variable name, to suggest that something is private, but you can still access it from the outside if you really wanted to. Now let's move into loops. Loops is another concept we already know from Python, but in different syntax. Java supports different kind of loops like for loops, while loops, or do while loops. The for loops follows this structure right here, and you can also nest the for loops just like in Python. Just remember to use different names for the inner and outer loops. And the while loops looks like this, and you use for loops when you know the number of iterations ahead of time, and a while loop when you don't. Java has two categories of variable, primitive and non-primitive. The primitive types are the building blocks, like int is the 32-bit integers. Double is the 64-bit decimal numbers. There's boolean is the true or false one, and the char, like char, stands for a single character, and few other like byte, short, long, float, and couple more. The non-primitive types are more complex. There's classes, interfaces, and arrays. The classes are like strings, integers, or classes you define yourself. Interfaces are defines the sets of methods a class must implement, and the arrays are fixed size collections of the same type. Because arrays are fixed size, Java also gives us an array lists, which are more like the Python lists that can also grow and shrink dynamically. The integer is the Java generics. It specifies what type the list will hold, which ensures the safety at a compile time. Common methods includes mylist.add, mylist.remove, mylist.get, mylist.size, mylist.contain, and each one means different thing, such as like add an element, remove an element, true and false, and more. Alright, let's wrap up with a quick OOP recap. The OOP, which stands for the object-oriented programming, is built around the idea of objects that has fields or data and methods, and Java is built around this principle. We looked at a coordinate plane in both Java and Python. But in the Java version, it just looks more verbose, as we talked about. It's just structurally the same idea. Define the classes, give them a field and methods, and use them both together. And lastly, the last major topic is inheritance. It's one of the pillars of OOP. Inheritance lets a subclass inherit the fields and methods of the superclass, which is the parent class. In Java, you do this using the extend keyword in it. One important thing that comes with inheritance is the method overriding. If a subclass needs a different version of a method from its parent class, it can override it. As long as you use the same method signature, and it doesn't use more restrictive access modifier. And that was the whole week 1 contents. We covered what is Java, how it compiles, some key syntax difference from Python and Java, some loops, data types, arrays list, and a review with OOP with inheritance. Hope that was helpful.